going old school here. When we get back to trying to work out how to go about drilling all these guys. So we went back over the sine bar stuff, and just to go and play old math for a while, or as they say at home, maths, I calculated the height based on the 5-inch sine bar, and did a little bit of trig here and just backed into everything to make sure that the numbers made sense. So going to trigonometry, the sine theta is the opposite over the hypotenuse. The opposite of the angle we are looking for is this guy. The hypotenuse is that one. Plug it in, do the inverse, and we get 22.086 degrees. Old school, we would have tried to work out what is our constant. And to do that, we would have just divided 1.88 by 5, and we would have came up with 0.376 using our calculator based on the decimal points. Then we would have went to our trusty natural trig tables, and we would have gone through scrolling along until we could find 0.376. And you kind of just quickly scan through and find where the sine numbers are coming up, and we ended up with 22 degrees 5 minutes, which gave us the 22 degrees 5 minutes equals 1.8797 inches of height, which is pretty close to our 1.88. So everything came out in the math. Now if we were trying to find the height of the bar we needed for 22 degrees 5 minutes, we would have went to the sine bar constants, gone to 22 degrees, gone 22 degrees 5 minutes, gave us the sine bar, the gauge block heights of 1.8797, but close enough to 1.88 inches. So we now know what the angle we need to set the head of the dividing dividing head. The angle the dividing head chuck needs to be at, so we can then now drill our holes at the right angle. The other issue we had was, we know that we had 5 ports per offset, but the next one was offset from that. The next row of ports was offset from this row of ports. So it looked approximately like half the angle, so they gave us 36 degrees. So the first 5 we'd rotate at 72 degrees, come back around. The next time we need to advance 36 degrees to start our very first one. Then we go 72 degrees from that, and that would give us our offset. This muzzle brake, basically it has 1, 2, 3, 4, 5. Offset it. It looks like it's half the angle. And there we go. So that gets us there. The next issue we have, we've got to locate the center of the holes we're going to drill. Now, my Bridgeport is not set up for me to set it the head this direction and come down that way. I'm going to be setting my tool based on this edge, this way, this way, this way, until the last one. So I need to convert the linear dimensions these guys are at to the horizontal, so I can adjust my feed in accordingly. So using the pin gauge again, I checked the hole diameter, it was 0.217. divide that in two, rounding of course. I'm not worried about being you know, making spaceships here, so I'm not going to worry about, you know, rounding errors too much. So they gave me 0.109. I then measured from the edge of the muzzle brake to the edge of the first hole, which was going this way, 0.11 inch, plus or minus a couple of thou. Oh well. Then I know the center of it is 0.109 away from that. So the center of my first hole from the edge, because I'm going to use the edge finder to locate that and then start moving in, is 2.19. However, I've got to convert it to edges this way so that I'm moving my slide the appropriate amount. So back to our trig angle of 22.8086 degrees, I found that this one, and that's using Pythagoras theorem of, you know, sine, hypotenuse squared subtract the height squared equals the length of the other side. So I converted 0.219 to my first dial dimension to be 0.203. That locates my first hole. Now if I'm to go on the same track, I got to jump over the next line, go directly across, and that would be 0.704. So I converted that to the linear dimension as 0.625. So my first dial movement is 0.203, drill the hole, mill the holes, index around, all the other stuff I'm going to do. Then I move my slide to 0.855 and repeat all those processes again. But in reality, what I'm going to do is advance it, do the first series of hole, then the second series of hole, and the third series of holes, and the fourth series of holes. So I've got to go 0.0203 to do the first set, rotate around 72 degrees, 1, 2, 3, 4, 5 times like I did before. Move the cross slide half this amount, which is going to be, using my calculator because it's too late at night for me to think, is going to be 0.652 divided by 2. Got to go 0.326. So my dial is actually going to be 0.203 plus that. So my first indicator movement is going to be to 0.529. So I don't want to go backwards and forwards setting my slide and resetting to 0, making sure I'm right. I'm not using a DRO, so I don't have the fancy digital readout to just glance at. So I'm going to go 0.203, drill my first hole, 0.529, do my next series, then 0.855, then finally, once I get to 0.855, I'm going to do it one more time, 0.326, and this last one, my dial is going to be 1.181 inches. Then do the final series.